So now let us look to the specification and the implementation of a perfect failure detector, P. So here is specification of a perfect failure detector. The instance is called P. And we have one event. It's an indication event, which declares that process PI has crashed. So it notifies that PI has crashed locally to its own process. So here is component P, and it basically outputs the event crash PI. And what are the properties of P? It has strong completeness and strong accuracy. Again, strong completeness is saying the following: eventually, every process that crashes is permanently detected by every correct process. And strong accuracy, and strong accuracy says if a process P is detected by any node, then P has actually crashed. So these properties are the safety or liveness. So let us take first strong completeness. Strong completeness is a liveness property because it is an eventual property, whereas accuracy is safety, and the bad event in this case is detecting a crash process, but the process did not crash. Now here is a possible implementation of P. So we assume a synchronous system. And by assuming that, we are saying that the max transmission delay of messages is between 0 and delta time units. So if you send a message, it will arrive to the destination within this period from 0 to delta time units. And here is how the algorithm works. Each process, every gamma time units, sends heartbeat to all processes. And each process waits gamma plus delta time units. And if that process did not get a heartbeat from process PI, then it declares that PI has crashed. We say it again from the perspective of PI. So PI, every gamma time units send a heartbeat. And now let us look from the perspective of PJ. If PJ did not get a heartbeat, say from process PI, did not get this heartbeat from process PI, after gamma plus delta time units, then it declares that PI has crashed. Let us reason about the correctness of P. To reason about the correctness of P, we reason about the correctness of the two properties. The one is strong completeness, which say that every crash process will eventually be detected. So let us see this property first, and then we will reason about strong accuracy later. So a crash process does not send a heartbeat. So eventually, every process will notice the absence of the heartbeat. And as we have seen, actually a process will declare that another process has crashed if it did not get the heartbeat within gamma plus delta. So again, see this from the perspective of PI. First, we say a crash process does not send a heartbeat. So from PJ's perspective, if PI is alive, it should get the heartbeat within this period. This is the last time it got a heartbeat, But if it did not get a heartbeat until this point, then it will consider the process has crashed and declares that the process has crashed. So let us look now to strong accuracy. Assuming that the local computation time is negligible, then the maximum time between two heartbeats should be gamma plus delta time units. Let's look here. If this process Pj sends a heartbeat, so it arrives here, but let us look now to the next heartbeat from this process. If this process is alive and well, its heartbeat should arrive in this period within 0 and delta time units. So if Pi is alive, Bj will receive the heartbeat from Pi within this period, the period gamma plus delta. And if it didn't, for example, because this process has crashed, it will not receive this heartbeat, and it should be accurate because it should receive the heartbeat within this period.